make it as a new chapter. Making salts should be considered as a new chapter. In the test, in the test, they have identified 3 topics: acids and bases, oxides, salts, identification of ions, and redox.
Okay, done.
Now we are starting our concept. We are putting our first concept in this article, that salts are ionic compounds. Normally, when you talk about salt in its conventional meaning, a salt contains a metal and a non-metal. A salt contains metal and non-metal. For example, sodium chloride, magnesium chloride. So a salt contain a metal and a non-metal. The famous salts are sodium chloride, magnesium chloride. This is a general definition. There are many other salts available, but I put my first classification here. There are 2 types of salts, one which are called soluble and second which are called insoluble or sparingly soluble. Now remember this concept, that barium sulfate, lead sulfate are called insoluble salt. Like sodium chloride, which is our home salt, we use it at our home. It's a very, very soluble salt. So salts are considered as soluble and insoluble in their nature. You have to now copy this distribution. No need to copy the common salt 3 lines. Copy this concept that there are 2 types of salt, soluble and insoluble. Now, these are the salts you have to memorize: soluble and insoluble salts. Some salts are soluble in water and some salts are insoluble in water. I will, did you try to print out that one very important document I had asked you to print?
Yes, I did.
You did?
Yeah.
Oh, very good. So I will share with you a list of soluble and insoluble salt. You have to memorize. Normally, I give you, what we have to remember: group 1, group 2, they normally make soluble salt, sodium salt, potassium salt, magnesium salt. Group 1 and group 2 salts are generally soluble. Salts of silver, salts of barium, salts of lead are generally insoluble. So I put my second concept for today. This is my second concept. Group 1 and 2 form soluble salts. What's the meaning of soluble salt? Soluble salt means they are soluble in water. Normally, the term solubility is used in sense of, the term solubility is used in terms of solubility in water. Okay, now this is a thumb rule. Group 1 and group 2 salts are generally soluble. I will share with you a chart which you have to memorize. What are the famous groups which are not soluble? Look here. Salts of silver, lead. Salts of silver, lead, and mercury are sparingly soluble. So what is the concept to memorize? Silver salts are generally insoluble. Lead salts are generally insoluble. Mercury salts are generally insoluble. They do not make soluble salts. Now we put our next concept. This is a very important, very helpful concept, and this is a unique concept for nitrates. I put my next concept. You have to memorize that all nitrates are soluble. For example, sodium nitrate, silver nitrate, all nitrates are soluble. So whenever you see this NO3, Mikhail, whenever you see NO3, you will understand, you have to remember that all nitrates are insoluble. Oh, sorry, all nitrates are soluble. So this is a memory to remember that all nitrates are soluble. Can you repeat? All nitrates are?
All nitrates soluble. But
Yes.
I have a question. How will they ask questions for this?
This is again, right now, what we need here, Mikhail, there are two types of salts, soluble and insoluble. The preparation method depends upon their nature. So he can ask you how you prepare sodium chloride. So first you have to know, is it a soluble salt or it is an insoluble salt. Right now, in this chapter, we need this information because according to the nature, we will tell the examiner the method. For example, barium sulfate is a very insoluble salt. So the method will involve precipitation. Sodium chloride is a soluble salt. So the method will involve evaporation. For example, I ask you to separate sand from water. You know, sand is not soluble in water. So you will suggest me filtration because you can filter out the insoluble material. So the knowledge of soluble or not soluble is necessary to decide what method you will use. For example, sodium chloride cannot be separated by filtration. Why? Because sodium chloride is a soluble salt. But if you evaporate water, like we use this method for removing salt from seawater, and a very interesting natural example that when the clouds form above sea level, clouds do not contain salty water, even though the clouds form over the sea, and seawater is terribly salty. Seawater is terribly salty. But what's the benefit? The benefit is there that when the water evaporates during the cloud formation, salt remain in the seawater. So this is the theme here, that salts are soluble or insoluble. We need this information to decide what will be our method. Okay, so for example, silver chloride, for example, for example, Lead. Lead is Pb. Lead is Pb. So for example, Pb, lead chloride. Nitrate is an exception. Nitrate is an exception because all nitrates are soluble. So you remember these names also in chemistry. Memory is really very helpful. And as I told you that obviously the portion exams are also very important. But the biggest issue in the final year is the mock one. Actually, mock one creates a lot of pressure because a lot of course will be coming. When in the February, they will take the final mock. Normally, schools take it in February or in March sometimes, but by that, everything is covered. So now I put my next concept. Look at the concepts. It's a very important concept to remember. All carbonates are all carbonates are all carbonates are insoluble except group 1 and group 1 and 2 carbonates. So can you now remember it? For example, now make an example here. For example, calcium carbonate is insoluble. For example, sodium carbonate is soluble. Now you can differentiate here soluble and insoluble. Now, can you repeat this concept about carbonates, Mikhail?
All carbonates are insoluble except group 1 and group 2 carbonates.
Except group 1 and group 2. So periodic table is always given. I have shared with you a table of a PDF of some important tests in actual exam of Cambridge. This sheet is given in paper 6. But in paper 1 and 2, it is not given. Right now, your school is not focusing on ATP. So you have to memorize this sheet. This will help you a lot in this Wednesday exam, like the test for gases, like the test for ions, like the test for halide ions, the carbonate ions, and also the response on the detection of color. It's very important. Actually, there is a flame color. I mean, this is very important to memorize the flame colors. This is very important to memorize the flame color. Why? Because you cannot actually identify the color in your own idea. There's no way. You have to use the class test actually. This is something I always advise that I also share videos. You should also make a search. Some GCSE videos are very helpful. If you have done flame test, 2, 3 flame tests in your school, then it's fine. Making soluble salt. Now give the heading, making soluble salt. Acha, what is making soluble salt? Soluble salts, like I hope you got the concept now. Again, Mikhail, this is a laboratory feature. This is a lab-related concept, and for that, always rely on some videos, some animations, because theory cannot make a clear concept until you watch a video. Last time I had shared with you a video of soluble salt. I hope you could see it. So these videos really make a good concept. What's the meaning of soluble salt? Like in home, you use sodium chloride. Sodium chloride is a soluble salt. So when something is soluble in water, you can remove the soluble salt by primarily a method called evaporation. If you put some salt in water like sodium chloride, it will dissolve. Now, after the dissolve, you can't separate it without any proper method like evaporation. Why evaporation? Evaporation actually take out water. Water will go out. Water will go out in that way. What will happen? Salt will be remaining. Acha, another approach here is what happens after evaporation? After evaporation, the salt will be remaining. If you go to a seaside, you will see some places on the shore are having deposit of salt because there was water also, but water evaporated. After the evaporation, the salt which remains in the bottom can be crystallized or can be scratched out. Normally, our course want us to do crystallization. It is in look in the screen. Soluble salts can be prepared by reacting an acid with an alkali, and this is a very common technique which is called acid base reaction. It is important to ensure the correct volume of acid. See, I emphasize a lot. This is again a part of paper 6 because you cannot randomly add an acid or a base. The correct volume of acid to be determined for using a titration. Right now, we are not doing titration because it is not looking to me in that syllabus which you have shared. But I asked you last time also, have you ever done titration in your class, like a long burette and an indicator added to a flask? You add drop by drop and then you shake the flask and a color change occurs?
I think we did that in the lab.
You have done it?
Yes, in the lab.
No, no, obviously in the lab, have you done it?
Yes.
Okay, so that's very good. So that's a very good thing because you know we are now discussing this method. So give the heading making soluble salt. The method I'm adopting is acid and alkali. So now after making the heading, copy this bracket. Soluble salt can be prepared by reacting an acid with an alkali. You will get a soluble salt. Now, remember this concept that you need a proper volume calculation here. Look at this apparatus. This is called titration apparatus. I'm using HCl and NaOH. One of them, HCl or NaOH, one of them will be in the burette and other one will be in the flask. I will add one by one, drop by drop, drop by drop, and I have an indicator to identify the neutralization point. You have to introduce a suitable you have to introduce a suitable indicator, which we have already discussed, and we have to wait for the color change. Now, this method is called titration. Now, color has changed. The endpoint has been reached. Now, repeat the titration, and then you will identify, you can identify the procedure. And after titration, we use evaporation. Why evaporation? Because once the salt is produced, salt will dissolve in water because salt is soluble here. A soluble salt can be separated by evaporation and followed by crystallization. Titration apparatus say acid in burette and alkali in flask. Run acid into the flask, indicator shows and point. Then a very important thing, the salt will not be separated itself because it's a soluble salt. So you have to evaporate the solvent and the salt will crystallize. You have to copy this concept map.
Done.
This is the procedure. Now, after leaving the solution to evaporation, look, this is the way the salt will appear. This is sodium chloride, which is also called in our common life table salt. We use it in our common life, and this is in our home. Now, all nitrates are soluble. We have discussed this before also. Now, making insoluble salt. Give the heading, making insoluble salt.
Done.
Now, what are insoluble salts? I had given you an idea. I had given you an idea of insoluble salts like lead salt, barium sulfate is a famous insoluble salt. Barium sulfate is a very famous insoluble salt. Silver salts, lead salts are insoluble, or carbonates of except group 1, 2, the carbonates are insoluble. So we have a method here which is called precipitation reaction. Insoluble salts can be prepared using a precipitation reaction. What is a precipitation reaction? A reaction which generates a PPT, a reaction which generates a PPT, and PPT means which doesn't dissolve in water and it settles down. So after giving the heading, you have to copy this bracket only.
Done.
Good. Now look at this, huh? Lead nitrate plus MgSO4 is making lead sulfate, which is insoluble magnesium nitrate. Now, remember that when you see this reaction in a laboratory, it is an insoluble salt and it will appear like a white PPT. You can look at in this diagram. This is how we can prepare a precipitated salt. So this is an example, and remember this concept that
Yeah.
all nitrates are soluble. So you have to copy this example.
Okay. But isn't magnesium soluble?
Magnesium sulfate. Look at the state symbol, Mikhail. State symbol is aqueous. It means soluble.
Oh, yeah.
Aqueous means soluble. Acha, when you write solid, it means it is insoluble. Aqueous means soluble.
Okay.
Magnesium belongs to group 2. Okay, now remember the thumb rule. Remember the thumb rule. What is the thumb rule? Group 1 and group 2 salts are soluble. Lead has a nitrate which is soluble. On the right hand side of the equation, this is lead sulfate. Lead sulfate is insoluble. Have you copied the equation?
Done now.
Okay. Once you have copied the equation, look at this PbSO4, right under it PPT.
Okay, done.
Now look at this appearance. This is a white PPT settling down in the reaction. Now, now I'm continuing after that. Obviously, once the salt is formed, you need a separation. So how we separate insoluble salt? The first step, the salt is made. It's a precipitate. Precipitate means it settles down. It settles down. I'm using lead nitrate and magnesium sulfate. The reaction is shown on my right-hand side in the two beakers. I'm conducting the reaction. Then I will use a filter paper and a funnel that will separate them. A precipitate can be separated by filtration. Again, as I told you that this is something which always needs some video support or the real experimental lab experience. So the benefit, look at this experiment. This is a funnel with a...
In this video, we're looking at making an insoluble salt by a process called precipitation. Now, in everyday life, precipitation means hail, snow, rain, sleet, drizzle. All in this case, they also happen to be colorless, but the two words don't mean the same thing. And then I'm going to add some potassium iodide, and we're going to make lead iodide.
Now, look at this color. It lead iodide,
yellow, but also it goes cloudy to funnel, and hopefully, just to get it to sit properly, you can sometimes just dampen it a bit so it sits in the filter properly. And then we're going to filter off our yellow insoluble solid. Being insoluble, it shouldn't come through the filter paper. You will find that a trace of it does in this case because the particles are so fine, but most of it will stay in the filter funnel. And so what we're going to end up with is mainly a solution of soluble products, solid there, but not so much as we want to worry about. Lead ions going into a river. So if a factory that's been working with lead
So this is the concept of, let me share this video so it will remain in our reference. I have shared the video and my advice would be to watch it very after the class because the theoretical concepts in these type of topics never get complete when you see these written screens. They can't replace a video, they can't replace a real experience. Combine the two solutions in a beaker, wait for the reaction, then use a funnel, wash the residue on filter paper and dry it. This is the conceptual sequence of separation of the salt. So now you have to copy this.
Done.
So now this is the procedure you have to memorize this procedure. You have to memorize this procedure. Now this is a summary to memorize. Now we should also make our understanding before we close this chapter that the title of this chapter was making salts. Okay. Now you have to remember that there are two types of salts. One are called soluble salt and the second are called insoluble salts. Okay.
Sir, I have a question.
Please go ahead.
When you filter this mixture of soluble and insoluble, I mean, oh wait.
Acha,
So when you filter the salt, where does it go?
it will remain on the filter paper. You saw the end video, na? It was on the filter paper. And if you need that salt, you can take it. It will be on the filter paper. Have you seen some houses are equipped with water filter in their home and they filter the water? There are 2-3 cylinders in the taps and they filter out water. What happened to the filtrate and what happened to the separated amount? It remain on the filter surface. For example, lead barium sulfate. You need barium sulfate. So after filtration, you open the filter paper, you dry the filter paper, and after drying it, you can use it. You can separate the salt from it. If you do not need the salt, then throw it out. For example, in many Gulf areas now, they are distilling, they are cleaning, purifying the seawater. So they are using a double feature. They separate salt from the seawater. They need the water also, and they need the salt also. So they separate both the things. It remain on the filter paper. Now let's make a summary together before we close this chapter. This chapter is complete, and let us make a summary together. And Okay, so now let's make a summary together. We have a feature of our salt. Okay, I'm sorry. I start with salt. The salt can be soluble or insoluble. Okay, a salt can be soluble or insoluble. In case of a soluble method, we can use a titration method. What happens inside titration method? Acid plus base gives you salt plus water. Okay, you can make the salt by using this method. Here, what you do, you make a reaction between two soluble salt. Reaction between two soluble salt. You saw this method here. I want you to revise it with me because titration is not very common. Using a precipitation reaction. Now we want something to precipitate because we can separate it by filtration. Now this is actually called precipitation reaction. Okay, now let's move together forward to complete this summary. Acha, then what happens if I go forward, Mikhail? If I go forward here, I will use the method of, after that, I will use the method of evaporation, which should be followed by crystallization. Okay, here. And here, I will follow the method of filtration. After filtration, the salt will be on the filter paper. So after filtration, we will use the concept of drying and crystallization. Now, this is a summary. So please copy down this summary. Let me know once you have copied it.
Okay, now I'm done.
Good. Now this chapter is completed, and this is a organized sheet. I will send it to you. This chapter is completed. Our main area is completed. The test topic, actually the chemical test. This is a chapter which is like a memory. I show you, there's nothing to discuss in it. But in your coming test, it's a solid mark paper, solid mark question. There are multiple tests in our chemistry course, like, for example, involving gases. For example, look at the screen. Hydrogen makes a squeaky pop sound when it gets a flame. Oxygen relights a glowing splint. Carbon dioxide turns lime water milky. Now, this is a table I have shared with you an official PDF which you have printed also. Do not forget to memorize it. Now look at this. Wooden splint are used to test for both hydrogen. When bubbled through lime water, carbon dioxide causes the solution to turn cloudy. These are some famous litmus paper tests. Litmus paper turn red in acid, turn blue in alkali. Flame test. Flame test is something which is very important. And if you have done it in your lab, then you must remember it. Every particular metal has a standard color. Normally, the Bunsen flame is blue. Normally, the Bunsen flame is blue. And when you put a metal, look at different colors are obtained. Lithium burns with a red flame. Sodium burns with a yellow flame. Potassium burns with a lilac flame. And I have shared the PDF, so the colors are there. This is the sheet, and I have already shared the main PDF, so the official syllabus PDF. So it is not necessary to memorize this sheet or any other sheet, because there is some controversy over the colors. Sometimes some teachers say lilac, some teachers says a bit different color like red, brick red. So in order to get out this problem, the official Cambridge PDF is used. Like here you can see blue PPT. Then second color is sludgy green PPT. Now obviously some people write it dirty green. So this is where you have to rely on the PDF I have sent to you. This is a syllabus PDF. Like here, aluminium, cobalt, these are called the test. Now look at these colors. Some of them you might have seen in your school lab, and some of them you might have not, but anyways, you have to memorize it. Now, this is a silver nitrate test, which I had shared with you yesterday, a very important file, very important screen, that what happened with when you add silver ions with these halogens. Look at these colors. Please go ahead.
Give me 1 minute. It's
Huh?
a 1 hour.
Can you please repeat?
I said there's someone at my door. 1 minute.
Okay, sure.
Yes, I'm back.
Okay.
Go back to the second slide. I want to take a screenshot of the test for oxygen, carbon dioxide.
But do not take a screenshot here, because that will, again, I told you the same confusion. The colors here are coming from our official websites, but the real color to mention is in that PDF. If you open the PDF, you will find all the tests in the official syllabus required color. So for example, sludgy green is not acceptable. They want some other dirty green word. So do not take any screenshot here.
The one for gases.
Even for gases also, you will open the PDF. You will find a very nice table with official syllabus language. If you open the PDF now, you can see it. And that's why I had shared with you a single PDF you printed before the paper, and you told me you already have printed. So that's easy for you. Test for water. Achha, now this is the test I want you to discuss with me quickly, because it is not in that PDF in a proper way. It is there, but not in a proper way. How we test water? Test for water, we put coppers and hydrous copper sulfate, which is white. If it is water, it will turn it into blue. Now, this is the test. If you want to test a liquid in a laboratory, it can be anything. But if it is water and you put it on copper sulfate, it will turn white copper sulfate into blue crystals. Look, these are the blue. This is the second important feature. So what is the test? If you want to test water, look it carefully. If you want to test water, take some anhydrous copper sulfate, which is white in color, and put some water on it. And if it is really water, it will make it blue. Look at the second test. Pure water will always have the same melting and boiling point, 0 degree and 100 degree. So what are the two tests, Mikai? Copper sulfate turn blue when water is added to it. Second test, water boils at 100 degrees centigrade. Okay, so we are done for today. Chemical test is done. Acid bases are done. Salt formation is done. Redox is there, but I have a feeling that we have discussed redox. But if necessary, we can revise it again. But I have a feeling that we have discussed redox in electrolysis. In electrochemistry, redox means reduction and oxidation. Oxidation means gain of oxygen and loss of electron. Reduction means loss of oxygen and gain of electrons. Okay. So you have to start your preparation for acids and bases. The test is on Wednesday, and I think we will have a class before that, inshallah. But you know the pattern. We have done the work. You have to go through the work, you have to go through the notes and do some questions. Hopefully, you're going to get the past paper book today. Double check the topic list, everything. If it's suitable, then buy it. And then inshallah, we can do questions from those books. Okay.
Okay.
But somehow, if you do not get the book today, or if you get the book, in both cases, please update me and we can plan for our past paper, because we have to do questions before the test. Okay. So we are stopping here and we will continue inshallah in our next class. Allah Hafiz.